can't do. H of x is achievable by prefix codes, but only by certain distributions. Px, where Px has the form 2 to the minus Lx. We have, from last time, we had a theorem that the average length is greater than or equal to h of x. So prefix codes can't do any better. Than entropy. Okay. What this is telling us, P of x equals 2 to the minus Lx. What this is suggesting is that I should choose Lx. If I solve for Lx, this is suggesting that Lx should be negative log Px. But Lx has to be an integer. So how can I force this to be an integer? What's the notation for the smallest integer larger than this? It's ceiling, right? The ceiling operator. So what if I force this? How bad, how good or how bad is such a code? So firstly, we can show that if L of x is equal to ceiling, by the way, just so that everyone's on the same page, ceiling of x is equal to the smallest integer greater than or equal to x. So in other words, ceiling of 2.9 equals 3, ceiling of 2.1 equals 3, but ceiling of 2 equals 2. If Lx equals minus log b of x, then L of x satisfies the Kraft inequality. How do we show that? Well, what is the Kraft inequality? The Kraft inequality is sum over x of 2 to the minus Lx is less than or equal to 1. We're dealing with binary alphabets. Last time we dealt with general alphabets where we substituted the cardinality of u in here. But today we're dealing with binary alphabets, so it's 2. So what is 2 to the minus Lx? Well, 2 to the minus Lx is equal to 2 to the minus ceiling, negative log px, but ceiling of negative log px is greater than or equal to negative log px, just by the definition of ceiling. So if I take 2 to the minus something that's a little larger than, 2 to the minus something that's a little smaller than px, which is what log p, which is what this is, then this is less than or equal to 2 to the minus 2 to the minus log px. I can cancel that minus, which is equal to 2 to the log px. And what is that? This is px. Okay, so now let's take the sum. The sum over x. So sum 2 to the minus L of x is equal to this, sum over x of this, which is less than or equal to the sum over x of this, which is equal to the sum over 2 to the x of this, and that is ultimately equal to the sum over x of p of x. What's the sum over x of p of x? 1. And this is the Kraft inequality. So the Kraft inequality is satisfied. Why is that important? If the Kraft inequality is satisfied, what's the converse of the Kraft inequality? The direct statement of the Kraft inequality is if any prefix code, the lengths Lx satisfy this. The converse says what?
This doesn't satisfy that, it's not a prefix.
That's just a negation, but the converse is actually that if you were given Lx, then there must exist a prefix code that corresponds to them. So in other words, because these lengths, I just picked these lengths out of the air. I said let's pretend we have a code with these lengths. What I know is that because it satisfies the Kraft inequality, there must exist a prefix code with these lengths. So the implication is there exists a prefix code with these lengths. So if, what do we know about the length now? We know that L of x is equal to ceiling minus log p of x. So therefore, minus log p of x must be less than or equal to L of x, which is less than or equal to minus log p of x plus 1. For the definition of ceiling. Actually, in this direction, I think it's just less than, but who's counting? Let's just keep the less than or equal to. So, just by example, like 2.1, this would map into 3. So 2.1 is bounded. Excuse me. If log p of x is 2.1, or excuse me, if the length is 3 or something, that's bounded between log p of x, which could be anything from 2.1 to 2.9, and 3.1 to 3.9. So at most, the penalty is, basically this is expressing the penalty. This is what we want. Log px, that's the length we want, but if it's not an integer, the maximum penalty is 1 bit. So the worst case scenario would be if this was 2.000001, then we'd have to express it with 3 bits, and so therefore this is still less than 3.000001. So the penalty here is just less than 1 bit. So the maximum possible penalty that we can have is 1 bit.